One of the challenges with Legos, as well as some industrial controls, is getting angular position feedback. We can move motors, but don't know their position. So as we often do at NVE, we added sensors. We connected two non-contact I²C ASR012 angle sensors to an Arduino Micro single-board computer. One sensor is for the worm gear output, with a diametric disc magnet connected to the worm wheel. The magnets don't have to be very precisely located. The other sensor is off-axis from a ring magnet on the motor shaft. The off-axis configuration is convenient for tight spaces. In this case, the sensor is parallel to the magnet, but it also works perpendicular to the magnet. Let's power it up. The blue chart line is the motor shaft position in degrees. Green is the reducer output. The sensor resolution is 1/10 of a degree. The sensors can detect gear wobble, as you can see on the green line, since these are very precise sensors with not very precise gears. I²C is a 2-wire interface, so we just need 2 interface wires, power, and ground for each sensor. One sensor has the default I²C address. The other has an alternate address set by grounding a pin. A simple program reads the sensors and records the data. We can read a sensor in a single line. Other manufacturers' sensors have complicated interfaces. These are the parts we used for the demo. Everything is awesome about these sensors.
Everything is awesome.
We demonstrated their off-axis capability. They work with wide magnet air gaps, detect absolute position. They're precise, available in analog, I²C, or SPI interfaces. We used I²C for this demo. And they're ultra miniature. Click, email, or give us a shout for more information or to order sensors, evaluation boards, or magnets. Thanks to everyone who worked behind the scenes on this video.